Hey everyone, Mr. Fransky here. Going to do another little review video here. We're talking about inverse derivatives. And so students will be able to find derivatives of inverse functions here. This is one more topic that I was asked to do a review video on. So let's see if we can get a better handle on this topic. So vocabulary once again, inverse functions, buddy point, mirror point, you might also hear me call that. Mirror, wow, if I could spell. Mirror point, reciprocal, guess and check, and table. These are the kinds of things we're going to be looking at. So first, how to approach inverse function derivative problems when you're asked for the derivative of the inverse at a specific point. So the whole idea with inverse functions is you get the inverse function by reflecting over the line y equals x. So if the original function looks something like this, maybe, the inverse would look something like this, right? So the whole idea is if I know like the slope of the original function at a certain point, the buddy point on the other function, so the reflection over the line y equals x, the slope there is going to be the reciprocal of the slope right here. So if the point here is AB, this point over here is BA. So this is f of x. So f prime of x is equal to the slope of that tangent line. Let's call it m. So f inverse, which is this guy down here, so f inverse prime, that's kind of weird notation, but it works, of not a, right? So this is a over here. Not of a, but of b is equal to 1 over m. So they're reciprocals. Okay? So the way you should do this every time is you're going to put the point that's on f, and then you're going to find the slope, which you're going to get by doing f prime of, let's call this ab. So f prime of a, and you're going to find out what that is. Then you're going to say BA is on f inverse of x. And you get the slope, which is f inverse prime of what? Of b. And that's going to be equal to something else, and these guys are going to be reciprocals of each other. Okay, so that's kind of the key to doing these problems. So every time I need to see you making this. If you're not making it, you're going to make a mistake. I can guarantee it. Usually given like one piece of information here, you have to find the other one, but you can always piece it together based on what they give you. So let's take a look at some problems. Start out with a table. Excuse me. It's trying to find f inverse prime of -1. Okay, so some point is on f. Some point is on f inverse. And we're going to find the slope for each one. Okay, so we want f inverse prime of -1. We always put x values into derivatives, no matter if it's inverse or regular. We put x values into the function. So that is -1 is the x coordinate of the inverse function. That means it must be the y coordinate of the function itself, because those are going to switch places. So what I'm looking for is a -1 as the y value of the f function. Looks like that happens right here. That's my y value, right? This is x comma y. So that means 0 is my x coordinate because it corresponds with the y coordinate of -1. So that's a 0 right there. It doesn't really matter, but the slope of f at 0, 1. Now we go over to the derivative of 0, right? Because I'm looking for f prime of 0. And that is -2, which means the slope on the inverse at -1 is -1/2. Okay. They might ask you for a tangent line. Right, so it's important then to get this a y coordinate, but in this case we don't really need it. The only thing we needed it for was finding the derivative of the original function at 0, -1. Okay, if you haven't noticed, these are the problems from the Rainbow Review. So g inverse prime of -3. So some point is on g, some point is on g inverse. I'll find the slope at each point. So we know -3 is the x coordinate of g inverse, so that's the y coordinate of g. So I'm looking for -3 in the g of x column. There it is. That happens at 0. So my slope at 0, -3, it looks like is 4. So it's going to be 1/4. G inverse prime of -3, 1/4. Over here we got -1/2. F inverse prime of 0, so some point on f, the slope, some point on f inverse, the slope is. Okay, so 0 is my x coordinate of my inverse function, so it's the y coordinate of f. Looks like that happens at -1, so this is -1. Slope at -1, 0 for f is 2, so this is 1/2. Cool. G inverse prime of -1, some point on g, some point on G inverse. So negative 1 is my x-coordinate here, so I'm looking for it here. That happens at negative 1, so they're all negative 1s. So what that means is there's a point that's actually on the dotted line. So when you reflect it, it won't move. Right? When you reflect it over that line, it's not going to move that point at all. So at negative 1, our slope is 1, which means the slope of this guy is also 1, because the reciprocal of 1 is 1. Nice. Not too bad. All right, let's try some now with some equations. Given f of x is x to the 7th plus 2x plus 9, and f of 1 equals 12, find f inverse of 12. So let's set it up. F inverse prime, excuse me. Something on f, something on f inverse. And find our derivatives. So on the f function, they actually tell us 112 is on there, which means 12, 1 is here. So we want f inverse prime of 12, that's good, because that's the only x-coordinate we know anything about. So the slope here is going to be the derivative, which is 7x to the 6th plus 2, evaluated at x equals 1. Because we're plugging 1 into this derivative. This is the f function itself. We always plug the x-coordinate into the derivative. So that's going to be 7 plus 2, which is 9. Which means the derivative at 12 for the inverse function is 1/9. That's all you have to do. Nice. So now we're going to try when we're not given the point. So we got something on f. Hopefully you're getting used to writing this now. Something on f inverse. Slope, slope. Okay, so for this problem, we're not given anything except for the x-coordinate of here, which means the y-coordinate of here. Okay, so what we have to do is we have to figure out what x-coordinate gives us that. Let's try 0. 0 minus 5, nope, negative 5, doesn't work. How about 1? 1 plus 3 is 4, minus 5 is negative 1, that doesn't work. How about 2? 2 cubed is 8, 8 plus 6 is 14, minus 9, that works. Minus 5 is 9, right? So 2, 9, 9, 2. The reason we needed that is because I need to know what the x-coordinate is to plug into the derivative. So this is going to be the derivative, which is 3x squared plus 3, evaluated at x equals 2, which is 4 times 3 is 12, plus 3 is 15. So this guy is 1/15. Cool. This is one of the multiple choice problems on the packet you have, and it's just a derivative inverse problem. So let's see what's going on. So we got f of 3 is 15, f of 6 is 3. They're really giving you a table here. You could make a table if you wanted to. X values being 3 or 6, and f of x being 15 or 3. You can keep doing that. Some of these problems are easier if you organize them in terms of a table, but we can also just do it. So we got some point on f, some point on g, which is f inverse. Okay, so let's see here. They want g prime of 3, so that's my x-coordinate here. That means it's the y-coordinate there. So I'm looking for something of the y-coordinate of 3. F of 3 is 15. No, f of 6 is 3. That works. So 6, 3, 3, 6. And we want to know g prime. So f prime of 6, let's see if that's up here. It's negative 2. So g prime of 3 is going to be negative 1/2. Another 1/2. Cool. Hey, nice. I think that's it. So that's all I've got for you about inverse function derivatives. If you have more questions, of course, feel free to ask me. Otherwise, I love you guys. That's why I'm here. Have a great day.